In this presentation, we're going to learn a little bit about the interquartile range. The interquartile range is a measure used in the statistics to describe the spread of a set of data. When the interquartile range is small, it means the data is very close together, very bunched in the middle. And a large interquartile range means the data is very spread out. The interquartile range calculation is simply the difference between the upper quartile and the lower quartile. We're going to use some data in Excel to see how Autograph calculates the interquartile range. Here's some data on student weights. To put this into Excel, we highlight all the data, including the label at the top of the column. Right-click, copy, and then we're ready to go into Autograph. So we open Autograph, and when we do so, it gives us the 2D page. You notice the Y and the X axes. We need a 1D page, so we go to the top and click on New 1D Statistics page. With that open, we go to Data, enter raw data, and simply right-click Paste. That puts the data in there, and you'll notice that our title, Weight, goes in automatically as well. While we're here, we'll type in weights and we'll sort the data so that it goes smallest to largest. There it is, from 36 down to the bottom one, 70. And we can click OK. There it is. Nothing to be seen. We haven't asked for anything yet, but all there is to see is this here, which says that the weights data has gone in to Autograph. We've got two things we can do now. One is we can draw a box and whisker diagram like that. That just goes in nice and easy. And the other thing is to look at the data itself, which is calculated in this statistics box. If we ask Autograph to display that, we'll see not just the number in the sample, but the median, the lower quartile, upper quartile, and all sorts of things which will help us. If we want to use these values, it's a good idea to transfer them into the results box, which is like a notepad. So let's do that now, and we can close, and when we open the results box, we've got all our data here. Let's pull that open a little bit to see what's going on. Here's the data we were just looking at, but this is a form where we can copy and paste. So we can copy the data, and we're ready to start. If we want to calculate, we're going to need some of these numbers. So let's paste them into Word now and open our project on student weights. Paste that in. There we are. This is data we can use. You remember that the interquartile range was equal to the upper quartile minus the lower quartile. Do we know what that is? The interquartile range then here is equal to the upper quartile, copy, paste, minus the lower quartile, which is here, and paste. And using a calculator, we find very easily that the answer to that is 14.75. Now, there's one more thing that Autograph tells us, which I didn't mention, and that's this line here. The semi-interquartile range is simply half of the interquartile range. Sometimes that's useful for statisticians. So another way of finding the interquartile range was simply to double that number. 7.375 doubled is also 14.75. Back to our examples. A question in an exam would often give you the data in a form like this. If the data is not already in order, you have to do that. So put the smallest at the beginning and put them all in order until you get the largest at the end. Now, to solve this, we have to find the quartiles, the median, upper, and lower quartiles. We've got 11 numbers in this data set, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Now, how do you find the median? 11 add 1 is 12, and half of 12 is 6. So count along 6. 1, 2, 3, 4, 5, 6. Let's highlight that 10. That's the median. Just check it's 6 from the other end. 1, 2, 3, 4, 5, 6. Yes, there it is. Now, we don't want the median, we want the lower quartile and the upper quartile. So, what have we got down here? 3, 5, 6, 7, 7. Halfway through that little set of data, 3, 5, 6, 7, 7, is the 6. So that's our lower quartile, and 14 is our upper quartile. So the interquartile range that we want is 14, take away 6, and that's 8. Let's see if autograph can do that for us as well. Let's go back to our data, and our next set of work is this one here. Data. Let's copy that. Remember the procedure. Copy. Open autograph. Let's have a new page, a new 1D page. We can push this to the side if you think it's in the way, or even close it altogether. We can always open it again. And go to Data, enter raw data, paste. And here's some data. This, I think, was data on somebody's fast food survey. So we can put our data in here so we can sort it. It doesn't matter actually if you sort it or you don't sort it. This one is already sorted, so we'll leave that and click OK. There's the data. We shall open the statistics box. 11 in the sample, lower quartile 6, upper quartile 14. Distance between those two is 8, and half of 8 is 4. It seems to be all good, and the median is 10, confirms it. Transfer that to the results box so that we can use it. In the results box now, let's open up. Pull this to the side so we can see what's going on. There's the data. Let's copy that. Statistics for fast food. Copy. Now open Word. The results of our analysis we can paste directly into our word processor, and then we can say we've got the lower quartile, the upper quartile. The semi-interquartile range was 4, so the interquartile range equals 14 minus 6, which equals 8. 14 for the upper quartile and 6 for the lower quartile. The difference between them is 8. Finally, let's go back to autograph and see what this is actually doing. There's a box and whisker diagram. The interquartile range is the distance between these two quartiles. There is the 0th quartile, if you like, the minimum. The first quartile is the lower quartile. The second quartile is the median. There's the stripe. Third quartile is the upper quartile. The fourth quartile is the maximum, the largest value. Ours, remember, went from 3 to 19, and that's down here, 3 to 19. Our lower quartile was 6, upper quartile was 14, so that distance there is 8, and that is the median we've got there at 10. So we've got an interquartile range of 8 in this case. And that's interquartile ranges.